Welcome, everybody, to this week's Rising Tide Foundation lecture. I'm very, very, very happy that we have a very special guest, Dr. Gerald Pollack, who was brought to my attention many years ago when somebody had shared one of his presentations, and I don't remember now if it was at an Electric Universe conference or something, but I was blown away. I thought that the idea of water was something that we had really, all that could be said had been said. There's nothing really more to know about the nature of something that we've known for all of human history, that's very important to life, that composes a big chunk of the Earth's surface and everything which is living. And that, in my mind, naively, as is, I think, in the case of many people's minds, there wasn't really much of a difference in water contained that came out of my tap versus water that was contained in my body. Water is water, H2O. Then this presentation was presented to me, and Dr. Pollack really blew my mind. And more recently, I had been informed that on top of the books that he'd already published, Cells, Gels, Engines of Life, back over 20 years ago, there's been a new book, or a newer book, The Fourth Phase of Water, Beyond Solid, Liquid, and Vapor. Well, I've ordered my copy, and a lot of people, we're going to have links to all of those books in the description box of this video, like usual.
Thank you.
After the main presentation, we'll open up for Q&A, and I ask everybody, please put your name like usual in the chat box. I will call upon you in queue to ask Dr. Pollack a question, or if you want me to ask it for you, make it very concise and short, and I will do so. But otherwise, thank you so much, Dr. Pollack. The stage is yours.
Okay, thank you. And thanks for the invitation. I'm really happy to be here. Good way to spend a Sunday. So I'm going to be talking about the fourth phase of water and its implications, and I'm also going to mention. Whoops, I thought I advance the slides this way. What am I doing? Oh yeah, a surprising role of light in this. So the first question that's apropos of your introduction about, a lot of people think, well, water's been studied for years. There's nothing new about water, but do we really understand water? And so I'm going to show you a few examples, and my guess, I will bet that you can't explain them, and if you can't explain them, you really don't understand water. And so here's the first one. Here's a cloud sitting in the sky. And you probably haven't thought about it, but the cloud is made of little water droplets. The droplets are heavier than air, and so what makes the cloud float? And a secondary question is, the water is evaporating from here as much as it's evaporating from here. So how come there's a cloud here but nothing here? If you can't answer the question, you don't understand everything there is to know about water. Here's another example. You fill two beakers, each one with water. You stick an electrode in this one and another electrode in this one, and you impose a potential difference, a high potential difference. Here's what happens. First, a bridge forms between the two beakers. And then if you take a motor and move this beaker away from this beaker, a bridge forms. The bridge is sustained. And it's sustained over a distance of 3 or 4 centimeters indefinitely. Can you explain it? Again, same thing. If you can't explain it, you don't understand about water. Now, here's a lizard from Central America, and it sits happily on a branch or a limb of a tree. When it gets inspired, what it does is it jumps into the water and it walks on water. And because it walks on water, it's called the Jesus Christ lizard. How do you explain that? Okay, and I guess you can't. Perhaps you can. And this one's my favorite. This is a container, a trough filled with water. And some red dye is put into the water just for effect. You'll understand in a moment. And behind this container of water sits a magnet. It's a superconducting magnet, considerable power. And when the magnet is turned on, the Red Sea splits so that Moses could walk across it. This is for real. And, it poses some problems, especially if you're a fisherman and, so you may find yourself in some difficulty fishing without water. So I got my inspiration from this guy, Gilbert Ling. I had spent a couple of decades at least studying muscle contraction and how do the proteins in muscle come together to bring about the contraction that we all witness. And when I met him, I completely changed my field because he was advocating something. He was advocating that in biology the water is different. That the water is not ordinary liquid or I shouldn't say H2O because ordinary water. He said that the molecules were not like molecules in this glass of water where they're randomly disposed and bouncing around a fierce number of times per second or even per femtosecond. He said it's different, that the molecules are lined up like soldiers at attention. That was a radical view. On the other hand, when I met him and some others at a conference, he had piles of data to support his point of view, and so did other attendees at that conference. And I was really impressed. So I soon thought, this is so important because if he's right, then all of biology is wrong. And I tell you in advance that we found that in general he was right, but the specifics were not right, and there is an important difference in what he was espousing and what we subsequently found. Well, the first thing I did was to write a book, and the book that you had mentioned, Cells, Gels, and the Engines of Life. And this was 2001. And the book was intended basically to demonstrate the idea, or to share the ideas of Gilbert Ling. It went on beyond that, but that was the central idea, because Gilbert, brilliant as he was, had no capacity or limited capacity to share information in a way that was readily understandable. He thought that everybody was as brilliant as he was, and therefore all he had to do was sit down at either the typewriter or later at the word processor, bat out something, send it to the publisher, and that was it. It wasn't easy for readers, and so I decided to attempt to make it easy for readers by publishing this book. And the book received mixed reviews. Some people thought or expressed their viewpoint, oh, this is just more of Gilbert Ling, and we all know that Gilbert Ling is a crackpot, so pay no attention. On the other side were reviews like one from a well-known cell biologist from Harvard University, and of course, if it's from Harvard, you have to take it seriously. And he said, this book is a 304, I think, page preface to the future of cell biology. I like that one better. At any rate, I was inspired to follow up experimentally, because obviously this was so interesting. We had to learn more. And by the way, the book is selected among many by discerning readers all the time. And even this book does take a bit of time to pour through, but you can. So anyway, we started to do experiments, and we started with Gilbert Ling's central idea. He said, inside the cell, there are solids like proteins, which are 70% or so of the solids inside the cell. And the surfaces of the protein, for the most part, are hydrophilic. They have charges on their surface. And you can see here, these are water molecules, each one. And the water molecule can be represented by a dipole, that is plus at one end, minus at the other end. So you can imagine how the positive charge of this water molecule could stick to the surface here, and the opposite here, and so on. And you can imagine how the molecules of water would line up. That was Gilbert's idea. Now, conventional chemists, physical chemists, will agree that there probably are maybe 1 or 2 molecular layers of water that are organized this way. And as you go farther and farther, because of thermal motion, Brownian motion, this order gets disrupted. Gilbert said, no, that's not correct. It's not just 1 or 2 layers, but easily dozens, if not hundreds. And I'm going to show you later that in some cases, it could be hundreds of thousands of layers. That was an underestimate. So we began looking, and one of the features of this kind of water is if there's order, it's like a crystal. Now, crystals exclude contaminants or particles, molecules. You know, think of the ice crystal. If it's pure, then the water that contained the contaminants that was frozen, if the crystal is pure, the contaminants obviously need to be excluded. So we were looking for an experimental model where we put particles in, and if this zone, this ordered zone appeared, then the particles would be absent. That was the premise to start with. And we found it. We found it rather quickly. So this is a chamber, and the chamber contains a gel, and here's water. And we added particles to the water. You can see little particles here, they're little spheres. They're called microspheres, and they're widely used in all kinds of scientific studies. And we looked in the microscope, and at the boundary between the gel and the water, there we found a zone where there are no particles. And if we actually looked at the video, it became bigger and bigger over time. And it looked as though there's some zone that's growing and pushing out the particles. You know, and this was kind of astonishing finding. And we thought, well, it's interesting because possibly, at that time we had no evidence, but possibly the ordered zone, the crystalline-like water, extends for roughly 50 micrometers, which by chemical or biological standards is pretty big, you know, and there it was. And so we kept seeing this again and again. It was a repeatable phenomenon using various gels. And someone said, you know, you should give it a name, because why go through this long explanation when you can call it the X or Y? And he suggested we call it exclusion. This was an Australian colleague, exclusion zone, because obviously this zone excluded particles, and later we found molecules of all sorts. And it really works because exclusion zone, EZ, is easy to remember. Unfortunately, it doesn't work in every country because many countries it's EZ. So EZ water doesn't flow off the tongue as easily as EZ. And later, because we found that this zone of water differed in every respect from ordinary liquid water, we began to call this 4th phase water. And I will refer to it either as 4th phase or EZ or something like that. So we found, in terms of generality, we studied many charged hydrophilic surfaces, and not everyone generates this, but many, if not most, generate this. And we found that, again, many solutes are excluded. We obviously can't say all solutes are excluded because we never studied all solutes. How can you? So it's very general phenomenon that we're talking about. Now, the essential question is this water really different from ordinary bulk water? You know, I've alluded to the possibility that it's different, but I presented no evidence. Well, this evidence, this is a list of studies, evidence that EZ water is physically different from bulk water. The list was compiled about a decade ago. And if I were to give you a complete list, it would be actually now roughly twice as long. And so the finding is listed here. And the method is listed here. So, you know, for example, easy molecules are aligned, and that was found using polarizing microscopy and looking at birefringence, et cetera, et cetera. I'm not going to go through all of these because it's pretty much published, and anybody who's interested can do that. And I use all my time, and there are interesting things to be said. So I want to skip over this, except for this one. EZ has negative charge, or typically EZ has negative charge. And that is measured by electrodes, measuring the electrical potential. And so the way, this is a kind of summary of that finding, is that you have a surface next to water to begin with. And over time, this EZ forms, and it's, as I said, typically negatively charged, but you can't get negative charge out of something that's neutral, like water. All you can do is get some negative charge and some positive charge, because you have to, the sum of the two has to equal the original, which is uncharged. And we found that the positive charge was here beyond the EZ. So you've got negative here, positive here, that forms a battery. And the way it works is we were able to deduce is that we started, remember here, we started with water. And the water molecule looks like this. It's got an oxygen -2 and the hydrogens +1 and +1. And some energy comes, and I'll describe that in a moment. It breaks the molecule. And what happens is that this negative moiety, 2 - 1 plus, gets basically attached to this surface and kicks off the positive charge, which then goes here. So in many of these, molecules do the same and gradually build the first layer, and then the first layer acts as the template for the second layer, et cetera, et cetera. And so there are many layers that form, and therefore, excuse me, about to sneeze, you get a battery. Now the structure that allows this to happen, we were able to deduce, looks something like this. So here's the material, the hydrophilic material, and here's the water to start with. And from the water, we get these easy layers. And the first one forms next to the surface, and the first one acts as a template for the formation of the second one, and the third one, and so on. And so you get these build up one by one, another one, and another one, et cetera. And if you look at the structure looks something like this. It's a hexagonal structure. And as you know, throughout science, hexagons are, especially biology, hexagons are all over the place. So you've got oxygen sitting here at the vertex and hydrogen sitting in between. And if you were to count the number of hydrogens and oxygens in one unit cell, it turns out it's not H2O. If you think about it, it can't be H2O. As I said, it's negatively charged. H2O is neutral. It turns out, if you do the count, it's H3O2. Now, if you think about it, H4O2 would be double this, and therefore neutral. You take away one of the positive charges, one of the H's, and you get net negativity, which is what the experimental results dictate. Now, just one more feature that I should mention is, you know, this I suggested to you, or I presented an observation that this is negatively charged typically, and this is positively charged out here. Now, when you have negative and positive, all they want to do is join one another. But in this case, they don't. Now, why don't they? And the reason is that these holes are so small that for the positive charges to penetrate becomes a challenge. The positive charges are not just protons. The positive charges, the protons latch onto water molecules, forming hydronium ions, that is like a positively charged water. And the hydronium ion is simply too big to enter. Therefore, the positive charges, because they want to enter this negative space, but they can't, and therefore they remain here, and therefore you get the battery. Now, when you think about cells, what's going on inside the cells, well, essentially all the water is near a protein or other solid, and and therefore it's interfacial water. And as I suggested to you, since the surfaces are mostly hydrophilic surfaces, the water is going to be essentially all interfacial. And this grossly underestimates the crowdedness of the cell. So the cell is actually more or less filled with easy water, negatively charged easy water. And as you might guess, the cell has a negative electrical potential. And I argue that this is due to the easy water that sits in the cell. If those of you who are versed in biology will perhaps have learned that it has something to do with pumps and or transporters and channels that sit in the membrane. And I've argued in various places, anybody who's interested in checking it, that is simply not the case. And the negative electrical potential is due to the easy water inside the cell. Okay, now, one question that arises, could easy water contain information? And to those of you who are way outside this field, this may sound awfully strange. Information in water? What's that all about? Well, you know, to see whether this is possible, think about your thumb drive. And it stores information. How does it do it? Well, inside there's a sheet, a planar sheet of transistors, silicon-based transistors, situated at discrete points, a regular kind of array. And each one of these has two possible states. One is called 0, and the other is 1. And it's the distribution of the zeros and ones in this regularly arrayed series of transistors that convey the information or give the information. Now, I argue that in easy water, the situation is similar. So if you look at just one sheet, you can see that the oxygens and hydrogens are regularly arrayed. In fact, not only is there order in this two-dimensional sheet, but there's also order in this direction. So you've got that criterion is satisfied. Now, the second criterion is those transistors are either in one state or another state, 0, 1, on, off. Could that be true here? Well, it turns out that the oxygens can have not just 2 oxidation states, but actually 5. This is standard chemistry. You'll find it in standard chemistry books. And there's -2, which is called the valence. There's also -1, a 0, +1, +2. So the EZ, as I've demonstrated to you, the structure has all the capacity to store information. Doesn't mean that it does, but it has the capacity to do so. Now, is there evidence that water can store information? Well, perhaps a few of you know of the work of the late Masaru Emoto, who he took water and he put his intention to the water. He froze the water. He looked at the ice crystals and he looked at their shapes. And what he found is that if, for example, the early experiments, he played music instead of focusing his intention, and he played a Mozart symphony, and the crystals looked quite nice, and played John Lennon, and they looked, well, maybe even nicer. He conveyed his intention for peace, something highly relevant these days. And here is a sample of what he got, and thank you. And these are negative thoughts or statements. This is Spanish. I'm not sure of the translation, but it's something not pleasant. And if he plays heavy metal music, he got something like this. Now, his findings became very popular, but not among scientists. And the reason they didn't become popular among scientists is the method he used. So you know, he'd play a Mozart symphony to 50 Petri dishes. He'd freeze them all. He'd look at the crystals, And of the 50, he picked out the one that showed what he wanted to show most prominently. Obviously, scientists would never do something like that. And so among scientists, I know very few people who accept this as evidence. On the other hand, it's very popular. Now, I organize each year the annual conference on the physics, chemistry, and biology of water. And typically there are 2 or 3 presentations of all sorts among scientists showing the memory of water. And I guess I just want to show you maybe the most prominent one comes from the late, he died last year, Luc Montagnier. And he came each year for over a decade presenting his evidence for water memory. So I'm sort of truncating a range of people from a spiritualist all the way to a Nobel laureate who showed evidence for water memory. And what Luke showed is diagrammed here, and if true, it's astonishing. So he took a sample of DNA, a short sample, 100 base pairs, and put it in water or in a water buffer, and put it near a sample of pure water. And these were sealed, better than with a cork. There's no obvious way that that the information, that chemicals or chemical information could get from here to here. And his hypothesis was that the information was somehow, for example, electromagnetic or other kind of information getting from A to B. So he put them together for 24 hours, and he applied electromagnetic energy of a bland kind of nature, like 50 hertz or 60 hertz, waited for 24 hours, and again, hypothesized that there's some kind of information transfer of the sequence of this DNA to pure water. An astonishing finding, if true, as I said. So he then tested sample B to see if indeed it's occurring. And the way he did it was to use the PCR method that you all know about because COVID. So he used the material combined with the water, and voila, the new DNA that came out of this technique matches the sequence here, matches the sequence here. Now, that's nothing short of astonishing. On the other hand, so you might ask, well, is it real? It's been confirmed now in 3 different laboratories, 2 in Italy and 1 in China. So if we take confirmation in other labs as a sign that it's real, then it appears to be real. So I presented to you evidence from the 2 ends of the spectrum, from a spiritualist to a Nobel laureate, showing that there appears to be information that can be stored in water. So, if you think about what kind of water, it makes sense that it's easy water because easy water has the right criteria. Ordinary liquid water doesn't because the molecules are randomly oriented and bouncing around. That's no way to store information. So this is a possibility. So you can imagine sometime in the future that instead of being filled with a silicon chip, this is going to be filled maybe with easy water. And the advantage of that is the information storage is at the atomic level rather than at the transistor level. So we calculated, at least theoretically, this has the capacity to store information, information density of something like 1 billion times that of what currently exists. So if it's real, then it's possible that computers will be the size of pinheads. Now, a point of relevance for all that stuff is a finding that surprised me at first, that easy water, it's a kind of water, it's in between a liquid and a solid, sort of gel-like, can be solidified. You can get it solid at room temperature. And this was found by an Italian guy, Vittorio Elia, talented biochemist. And what he would do is he'd gather easy water, and it's always not so easy to gather just easy water. There's always some ordinary liquid water that surrounds it, puts it in a beaker, and you can see that the solid easy actually, or the easy water coalesces into something that looks like a cloud. And it's no coincidence because I don't have time to show you, but clouds are built of easy water. That's another story. Anyway, what he does is he dehydrates, gets rid of the liquid water, and he's left with this. And it forms a solid. So this is, for example, this is the solid at the bottom of this flask. And, he gave us a sample of it. We felt it. We did some experiments with it, and it seems to be real. And we've recently published confirmation of it, and using mass spectroscopy, spectrometry, we found that this is not an artifact caused by some contaminant, and we published that. So this is real. Now, the reason I bring this up is that if this ever comes into be, then it's pretty awkward to put a liquid in here, but it's easier to put a solid in here. So it may be that your memory stick may be filled with solid, easy water. This is something in the future. We don't know if it can work or not work, but theoretically it might. Now, I'm going to turn my attention to you and me. These people look healthy because all their cells are basically filled with easy water. Your cells, as Gilbert Ling was talking about, ordered water and massive amounts of evidence, but it's actually easy water that with the kind of structure that's slightly different from what Gilbert Ling was talking about. Your cells are filled with that stuff. And I'm going to be going into that and why that's important for your health and your function. But the original question, is easy water really physically distinct from ordinary bulk water? And the answer from that list that I showed you, which unfortunately I didn't have much time to go over it, the answer is yes. And the best we can judge is that it's a layered honeycomb structure with information storage capability. The storage capability is an aside, but I think interesting. Now, so the question you might ask is, well, gee, what charges the water battery? Every battery needs charging. You go to sleep and you forget to plug in your cell phone, and in the morning it's unusable till it gets charged again. And so it's normal for every battery to need charging. And since water, as I showed you, has the capacity to form a battery-like structure, the question is, well, where does the energy come from? What charges it, right? Because you can't get something for nothing. Well, the answer turned out to be light, incident radiant energy. And the way we found it, I shouldn't say that we found it. I should say that an undergraduate student in the lab found it. He was working on the lab bench, and I try to give these students a lot of latitude. If they want to try something, go ahead and try it. You're not a slave in the lab doing what the boss says you should do. Play around a little bit. And so he found there was a lamp, a gooseneck lamp sitting beside the chamber. He took the lamp and he shined it on, and this is what he found. So this is real data, and this is obviously a drawing. He turned on the lamp, and so here's a hydrophilic material, in this case Naphion, and we use this polymer quite a lot because it's very hydrophilic and it produces very nice exclusion zones. So here you can see the exclusion zone, and here are the microspheres. And typically the boundary between EZ and bulk water with microspheres is parallel to the nucleating surface. But when you shine the light, you can see what happened. This is his data. The exclusion zone expands. So he called me into the lab to see this, and I was obviously astonished because we were I was scratching my head for several years trying to figure out where the energy comes from. That's why I've, the hair is kind of missing here. But the student found it. He found that it was light that builds it. So I walk into the lab, and and then I say to the student, well, what happens if you remove the light or turn it off? What happens? And indeed, this disappeared, and in tens of minutes, it went back to a boundary that was completely parallel, just as it had been before he turned on the light. So it turns out that light is important. Naturally, the question arose, which wavelength of light? And so we then did real experiments done by professionals in the lab to find out. And we explored the full spectrum, starting from the short wavelength, ultraviolet, running through the visible spectrum all the way through infrared. And we found that the most effective of all was infrared light, that UV had no effect on any kind of expansion, and visible light, the full spectrum, had nothing. When you get toward the long wavelengths, toward the reds, there was a bit of expansion. And then into the infrared, that's where it really took hold. And we found that with very weak infrared light, we could expand this EZ by 10 times. So it really powerful infrared. Now, a lot of people don't really, are not so familiar with infrared light. They know if they have an electric range, they open the range, turn it on, and they could see an orange glow and feel heat, and they say, oh yeah, well, it's generating infrared energy. But it's more than that. Infrared energy comes from all over. And of course, when something is heated, it generates more infrared energy. And the sun, half of the energy from the sun is in the infrared range. That's why it feels warm. But you can prove to yourself easily that everything is generating infrared energy by turning off all the lights. Right. So you can't see anything. Your cell phone camera can't record anything. And you whip out your infrared camera, which is just like a regular camera, except that the sensor is sensitive not to visible light, but infrared light. And you get a beautiful image of everything. And that's why the military uses it at night to see what's around them. You get beautiful images of everything. So that means the energy is always there. The energy that's required for creating EZ water is always present to some extent. And therefore, if you have a hydrophilic material sitting next to water, what's going to happen is you'll always have some EZ water because the energy that's needed to build it is always there. And should you add more infrared energy, what happens is it builds. And if you remove that extra, it goes back to the original. So infrared energy is responsible. The energy for buildup comes from light, photonic energy, and in the infrared region, and it charges the water battery and also orders the water. Because if you go from chaos to order, you need energy. And I'm demonstrating to you an ordered form of water. So that's what the infrared energy does. It charges the battery, it orders the water. So it means that all you need to do is sort of sit in where there's lots of infrared energy, absorb the energy, and that's all. And so if you're paying attention and listening, you might say, well, boy, that looks pretty easy, especially the drink that's sitting here. But if that's all that's required, then this battery ought to be able to do work, right? Because it's getting energy, and energy is used to do work. And my guess is that there's not one of you sitting out there who have seen a glass of water doing work. I'm going to show you that a glass of water can do work. So, I mean, can this energy be harvested in some way? Well, it all started with another student, another bright undergraduate student, and we had just learned that Naphion, we use that a lot, this polymer, comes not only in sheets, but in tubes like this. It's like a straw. And I wondered whether, because it has curvature, I wondered whether still it could create an exclusion zone, either outside or inside. And so I suggested to the student that he look into it. And he looked into it, and very quickly, he immersed it in water in this horizontal position down here. And very quickly, he found that the answer was positive. Yeah, you could see an exclusion zone out here and one inside as well. He was pleased. Meanwhile, I was on a trip somewhere giving talks, and he wondered what to do next. So he used his initiative, and he started fiddling around, just like the student who illuminated his chamber. And one day, I'm back from my trip, and I'm sitting in my office with a visitor, and the student comes barging in. Usually, in my office, I leave my door half slightly ajar because I encourage people to come in and have a chat. But this student seemed almost rude, and I actually appreciated that he came in, because the visitor was not so interesting, and the visitor was going on and on, and the student barged in. So I pretended that I was irritated because he barged in, but he came and he said, I found something interesting, and I wanted to come in and tell you right away. So with some skepticism, I said, okay, what's so interesting? He said, well, I noticed that the water keeps flowing through the tube. It doesn't stop. And I'm thinking, if he's right, and it turned out he was right, if he's right, that's really interesting, because in order to have flow through a tube, you need energy. It's like, the flow through your arteries. The heart is pumping, right? And the energy comes from the heart muscle, which builds pressure, and you have a pressure gradient, which pushes the flow through. So where does the energy come from? Well, the only possibility that we could imagine is the one that I told you about earlier, and that is the absorption of infrared energy to the water, creating these interesting structures with separation of charge, etc. So I'm thinking, well, maybe that's the case. And that it was indeed the case. And the way it works is you put some water in the tube, make sure there are no air bubbles, and then you immerse it into water plus microspheres, just as before. Take it to the microscope, have a look, and there you see. Here's the Nafion tube, Nafion EZ, and the water and the spheres just keep running through. And we've had it going for a day and a half without stopping. Someone came into the lab, and we were demonstrating, and they said, well, that's not so impressive, because maybe it's something special for the Nafion tube. Why don't you try other tubes? And if you can see the same thing with other hydrophilic tubes, then, we'll begin to believe it. We couldn't find a tube, so we essentially created our own. And the way we created it is we took a gel. We actually took, and the gel starts as a liquid. And as it gels, we took a chunk of it, and we stuck a wire in, and it gelled, and we removed the wire, and we got a tunnel inside of a chunk of gel. We take the chunk of gel with the tunnel, and we immerse it into water and microspheres. So basically, we have the same kind of thing. Instead of a tube, we have the gel wall. Oh, is it? So you've got the gel here and the gel here. Here's the tunnel from here to here. And when it's immersed in water plus microspheres, the EZ grows next to this gel surface. The EZ grows next to the gel surface. And all the microspheres get pushed to the center. And as you can see, same sort of flow as within the Nafion tube. We tried a half dozen different gels and got a similar result, except, the speed and other characteristics are different for each particular gel. So it's clear. Now, it's clear that this is a general phenomenon, not just the Nafion tube. Another person came and said, well, you think all of this is driven by light? And that's pretty weird. Why don't you add light and see if it goes faster? So we did that experiment and we published it. We found that if you just crank up the microscope light, you can get it to flow at 5 times the speed. So so we clearly established that this is true, and it's a generality. So essentially, to summarize this, we've got a hollow tube in water, and flow goes, you might say, spontaneously through it, spontaneously. Work is done, so energy is required to do work. And therefore, we conclude that the energy absorption that I told you about, the infrared energy absorption, is necessary, unless somebody could come up with some sort of alternative energy source, which I'm so far hard to imagine. So water is really a transducer. It transduces light energy into mechanical energy. So in a glass of water, you can do work. Now, the question arises, this is an energy source that we're talking about, the infrared and EZ. Does the human biology use radiant energy to get it? You know, we all think that all of our energy comes from food. We eat the food, we digest it, we get various chemicals leading to ATP, which has a high energy phosphate bond, and that's how we get all our energy. But here, a different idea is proposed, that maybe there's an alternative source or a complementary source or something like that. Do we use, you know, plants do it all the time, and plants use light, and the question is, do we use light? So now, if you're Mother Nature, just think about it. It's hard to find a good image of Mother Nature. This is about the best I could find. I don't know if Mother Nature looks like this. Maybe you do, but whatever. But Mother Nature is smart, right? We understand that she's smart. And so she started with single-celled organisms and then green plants. And green plants use radiant energy. They use light. So question is, if you were Mother Nature and you got bored and you decided, hey, I've done it. Maybe I'll create animals. And then the question is, well, animals can forage. They can get food from plants or other animals. But I have this mechanism, this called photosynthesis. It works really well. You know, it's been around for a long time. Should I retain this kind of mechanism, either to complement other mechanisms or as a backup or whatever? I think if you were Mother Nature, you, instead of abandoning this method completely, you'd probably use it in some way. I'm not sure, but you know, it's not so easy to inquire about Mother Nature and what her decisions were, but this is a possibility. So we receive energy all the time, as I described to you, and some of the energy penetrates rather deeply. And one area is the cardiovascular system. And you've got capillaries that are just practically adjacent to the surface. And the question is whether, you know, hypothetically, is it possible? You know, we think we understand the cardiovascular system pretty well, but is it possible that radiant energy somehow, especially infrared energy, helps to power the cardiovascular system? Now, I wouldn't have thought so. I did my PhD modeling the pressures and flows in the cardiovascular system, and I thought we had it all worked out. And then one day, on a trip to Russia to see my friend and colleague at Moscow University, Vladimir Vyakov, he introduced me to a guy from a neighboring lab. And the guy was very eager to tell me stuff about the cardiovascular system. And I kind of, I must admit, I was feeling a little bit arrogant because I thought I knew what there was to know about the pressures and flows in the cardiovascular system. And the guy started telling me there's a big problem. Okay, so what's the big problem? The big problem, he had me convinced in 5 minutes that there was a big problem. The big problem is very simple. The red blood cells, that have to pass through the capillaries in the cardiovascular system are 6 or 7 micrometers in diameter. The smallest capillaries are 3 microns or 4 microns in diameter. So how do you get a big red blood cell to pass through a narrow capillary? It's like a plumbing problem. You know, you probably experienced it in your toilet. Sometimes it gets stuffed, and in order to relieve that, you use the plunger, and you plunge, and after a while it's eventually cleared. It's the same sort of problem. You got to take the red blood cell and you got to squeeze it, which requires energy. And so you can see in an actual cardiovascular system what happens. So the red blood cell is supposed to look like this. This is muscle tissue. It's got striations, and here's a capillary and another capillary and another capillary, and you can see that the red blood cells do get squeezed. They have to get squeezed in order to go through. And if you look at the video, you can see the squeezing and the flowing, and this guy is really squeezed, this capillary, having a hard time going through, and it requires energy. The question is, how much energy? The Russians are really good at these sorts of calculations. And this Russian guy calculated that if the heart were responsible, fully responsible, in other words, the heart develops pressure, which pushes everything through, can maybe squeeze the red blood cells, the amount of pressure that it would have to develop in order to do this is something like 1 million times the pressure that it actually develops. So, if you think about high blood pressure, this is high blood pressure. Well, obviously, if their calculation is right, or even if it's off by a couple of orders of magnitude, and we're still thinking about vast amount of energy that's needed to propel these cells through. Now, if it's not the heart, it's got to be something else, right? That in addition to the heart. And this guy was speculating about all kinds of potential mechanisms, including bubbles in the blood, and I wasn't paying too much attention because I was thinking. In our lab, we had just found that you put a hydrophilic tube in water, and the flow, it basically is spontaneous, or I shouldn't really say spontaneous because it's driven by infrared energy. And we're thinking, I was thinking, hey, maybe what's going on is the same mechanism that we found in the laboratory is occurring in the capillaries. Where in the lab we found that radiant energy, it builds easy here, it builds easy here, and in some way, I haven't described exactly how it drives the flow. We understand how it works. And the question is, might radiant energy help drive the blood flow? So we did an experiment to find out with positive results. We took a chick embryo. So here's the embryo in a fertilized egg, and the top of the egg shell is removed. And you can see that at 3 days, the embryo is developing, and by 3 days, there's a well-developed cardiovascular system. But the regulatory systems are not yet developed, well developed. For example, the hormones and the nerves and whatever. So it's a pretty pure system. And my student, Li Zheng, or Zheng Li, developed an optical system whereby he could look at either this vessel or this vessel, and look at the dynamics. So the first thing that he did, here's his main result, which, by the way, is getting published in about 3 days. This is blood flow velocity against time, and he checked the signature feature of the mechanism is if you apply infrared, it drives the flow. So first thing he does is he stops the heart, and you can do that by injecting potassium chloride in the heart. And to almost everybody's surprise, it's been reported in the past that if you stop the heart, you'd expect that the flow stops, but it doesn't stop. It keeps going. And a half dozen labs have reported this over the past century, but nobody pays attention. So there's got to be something beyond the heart that is actually driving the flow. And that's precisely what Lee found. He would stop the heart, you call it post-mortem, and the blood flow would go down. It didn't go to zero, it kept flowing. And then he tested the signature feature of the phenomenon, that is, you apply infrared, and you can see the result here. You got a roughly threefold increase in flow, and he removed it, and it went back down to the original level. So it appears that it's not just your heart that drives the flow, it's also your vessels, blood vessels. And this is, I guess, a sort of maybe an astonishing finding, but it looks as though that is the case in your heart and my heart. And we don't know yet the extent to which the vessels propel. In other words, what fraction, what proportion. The problem is that when you stop the heart becomes an obstacle to flow. And so any flow that's generated in the periphery is going to get blocked by the heart in this preparation. And so it makes it difficult to figure out just how much contribution is being made by the vessels. That remains for the future. Okay, so basically radiant energy does help drive blood flow in your and my cardiovascular system. So it doesn't particularly mean that we photosynthesize, because photosynthesis, is, I think, 20 steps or something like this. But the first step is the effect of light creating separation of charge in water. And that's roughly what we've been talking about during this whole presentation. So I'm not suggesting that we photosynthesize, but I am suggesting that we use light, the first step. In fact, photosynthesis itself might be one manifestation or example of a more general phenomenon that I've been presenting to you. Light supplies energy. Now, how does radiant energy facilitate function? Well, just think about what's going on. You've got negative EZ water practically filling the cell, and the cell is very crowded. So essentially all of the water that's inside the cell is that. Negative charges repel each other. They want to get away from each other because of repulsion, and that amounts to potential energy. Potential energy drives protein folding. Protein folding is essentially what cells do to do what they're designed to do. A muscle to contract, a secretory cell to secrete. It's all done by protein folding, and that is driven by this kind of potential energy. Evidence is presented in the book that we've been talking about, extensive evidence in many cell types. And so it needs easy water for folding and unfolding. Now, here's an example. You have a protein, and it's in an extended state, and it's surrounded by easy water. So what happens when it's activated, when the cell is activated, is that the easy water melts, and the protein is able to fold. And then when the action is over, it comes back to the original state. And that's the energy requiring step, something like that. Now, if there's no easy water around it, or not much easy water, then the cell can't it's basically impotent. And so it's dysfunctional or pathological. You need the easy water in order for the cells to function properly. Now, so the potential energy from EZ is actually driving the work of the cell. And just go through the process. Remember, light builds EZ. EZ has negative charge. Negative charge is potential energy. And the potential energy can do work or folding of the proteins. So if you connect the dots, light is responsible for the work of the cell, or light can be responsible for at least some of the work of the cell. So if you raise the question, where do we get our energy? Certainly we get energy from food, no question about it. But we also get energy from light. And it's something that we don't think about, but we get energy. The light is absorbed by the water, which builds EZ inside our cells and gives us energy. And so that you can explain then about people who don't eat. I just learned in a meeting in Australia that there are some 300,000 people who don't eat on a regular basis. These are not people, who are starving to death. These are people who have chosen to not eat for various reasons. And perhaps the most famous of all is Prahlad Jani from India, who passed a couple of years ago. Now, he claimed he went at age 65 or 70, or I think in his early 70s, he went to the government in India. He told them that he was approached when he was 7 years old by two angels. He lived in a sort of the jungle in a cave in India. And he claims the angels approached him and said, you don't need to eat. Actually, you don't need to drink either. It's a very humid area. So you can imagine that the humidity might have been adequate to supply the water. There are plants that actually survive that way without roots. Anyway, he went to the government. He said he hasn't eaten anything for 65 years, and he thought he had to report this to the government. So he reported it to the government, and they did studies, and they found nothing unusual about him. And then another guy, a physician, turned out to become a friend of mine, decided to do a study. They put him in a hospital room for 2 weeks, and they assembled a group of physicians. And he was sealed in this hospital room, no food possible at all. In fact, no drink either. And they assembled 15 physicians, a pulmonologist, a cardiologist, a urologist, every ologist you can think of. And they studied him for 2 weeks, and they certified that he ate nothing, at least during those 2 weeks. And they could find, and actually his bladder would increase in size and then decrease, but he never urinated. So they couldn't figure out exactly what went on, but that was what they could observe. And then at the end, as I said, the physician in charge, who became a friend, told me the story that he wanted to interview him after a couple of weeks in the hospital room. And the hospital room was on one of the lower floors, and his office was up high. And either there was no elevator or the elevator wasn't working, so they had to go upstairs. So this guy, after 2 weeks of no eating, he told me, ran up the stairs faster than he could run up than the doctor could run up the stairs. So it was very interesting. Anyway, the question is, well, where does he get his energy? And obviously it doesn't come from food. And so a possibility is that it comes from light energy, just like plants. So they're called breatharians, these people. Where do they get their energy? Obviously not from food. And one idea considered by many people is that they get their energy from light. So, for building energy and creating function, should all of this stuff that I told you matter to you, and so light really does matter, and water matters. And so you may want to know, you may be thinking, well, to stay healthy, what do I need to do? And how do you build easy water in your cells? And I was going to list a half dozen expedients that anybody can use to do this. First of all, drink a lot of water, because water is the raw material for building easy water inside your body. Green juicing, this may be new to some of you, but go to your backyard, take some leaves of freshly grown plants, crush them, squeeze out the water, and drink it. Now, the water you're drinking comes from inside the plant cells. These are fresh, healthy plant cells, and they're full of easy water. So you're drinking easy water directly. And and well, it's a peripheral point, but I think it's not the easy water that creates easy water in your cells, but I think it's the negative charge, the electrons from the easy water that penetrate in your body to wherever there's not enough negative charge, thereby building easy water. There are certain substances known for 5 or 10,000 years from Ayurvedic times that are good for health. Turmeric, coconut water, others. We tested a bunch of them, and we found that each one of them actually built easy water at concentrations that would normally exist inside the body. The best one of them was ghee, clarified butter, and we could find exclusion zones next to ghee of something like 1 millimeter, really large. Sunshine contains a lot of infrared energy, builds EZ. So going out in the sun can feel good to do that if you don't get burned. And the reason it can feel good is the sunlight is penetrating your skull into your brain cells. And we know it penetrates because imaging can be done with an infrared source outside, imaging the brain. So the infrared goes in, gets scattered by your neurons inside, comes back, and you can create an image. So obviously, the infrared does penetrate your skull. And you feel good because light, infrared light builds EZ. The extreme is sauna, or as the Finns say, sauna. And all it is heat, right? And heat is roughly equivalent to infrared light. And we know that builds EZ. So you walk into a sauna, or in Russia, a banya, same thing. And you walk in feeling maybe depressed or pains in some areas, and you come out feeling happy, better. And I think it's just because of the heat, infrared builds EZ. And finally, grounding or earthing. You connect yourself to the earth. The earth, it turns out, I hadn't realized until some years ago, that the earth is not neutral, it's negatively charged. And if you connect yourself electrically to a source of negative charge, the negative charge will penetrate your body and build EZ where there's no EZ or not enough EZ. And we found in the laboratory that all you need to do is pass electrons into the water, ordinary water, and that water turns into EZ water. And so that's what is achieved by connecting yourself to the ground, and you feel better. So those are some expedients. There are more that are relatively easy to do and should be good for health. I end with practical applications, if the above is maybe not practical. One of them is getting energy from water and sunlight. You got a battery, electrical charges are separated. And if you put one electrode here, you ought to be able to get electrical energy. And here I show that you can get it. So these are, I think, a dozen or so little chambers, each containing a piece of naphthalene, water, and 2 electrodes, with one electrode sitting in the negative, the other electrode in the positive, and connected together either in series or in parallel, depending on what you like, switch. And here's a LED, a light-emitting diode, and a magnifier. And so you turn the switch, and voila, electrical energy comes out. So we don't know at present whether this will turn out to be a practical application or not, but it's clear that there is electrical energy that can be obtained simply from water and light. Another one is getting drinking water from contaminated water. It's a kind of filter shown here, but there's no physical filter. See, this is different. So what happens is that you got flow coming into like a naphthalene tube or some other material. It doesn't need to be a naphthalene, and it may contain contaminants. As sample contaminants, we use microspheres, although we've used other real contaminants with similar results. And so what happens is that when it goes into the tube, you get an exclusion zone here and an exclusion zone here, and all the junk gets pushed to the middle. We've devised what you might call a differential extractor, which is nothing more than two concentric tubes, and the junk gets passed through the center tube and out here. And this water contains no junk, or almost no junk in theory, and we collect that. So, and you can see the difference between these two. And we've been able to separate, in one pass through, we've been able to separate something like 200 to 1 in concentration. So it's quite effective. And we've been able to improve the throughput. So again, there's no physical filter to clean or change. It runs on the energy from infrared from the sun. Now, we've been looking at also the possibility of separating salt. So the idea is you have ocean water that comes in, and the idea is to separate the salt. And we believe we have some preliminary evidence that it's correct. So the salt comes to the center. We dump the salt here, and this should be water that's drinkable from ocean water. Now remember, all you need is sunlight, and the places where this kind of where drinking water is needed are places where there's a lot of sunlight coming through. So it's possible, it should be possible in the future to get drinking water out of ocean water without using enormous amounts of energy that is now required to produce that. So I conclude, the main conclusion is that water has not 3 phases, but 4 phases. And I put the easy phase in between the ice and the water because first of all, its structure, hexagonal structure, is also seen in ice. But more than that, we found that in order to freeze water, you can't go directly from water to ice. You must go through the EZ phase. Therefore, it sits in between. And if you melt ice, you can't go, or the ice doesn't melt directly into liquid water. It melts into EZ, which then transitions into ordinary water. And that being the case, various seeming anomalies actually disappear. And the broad implications of this, the most central one is that radiant energy is being absorbed by water, and that radiant energy is not just wasted, it's used. I showed you one biological use, but there's evidence that it's used not only in the cardiovascular system, but actually in all cells of your body. And in terms of chemistry, you've all taken a course in, basic course in chemistry, I think, at least some of you, and some of the interpretations are complicated. But as far as I've seen, never has anybody taken into account the kind of effect of infrared energy, the charge separation that occurs broadly in water, et cetera. So it may be that many of the interpretations of reactions occurring in aqueous solutions will need to be rather substantially revised if what I presented to you is correct. Weather. In Seattle, in the wintertime, the skies are gray, and usually, or so often, we get a 50% probability that it's going to rain. It doesn't help. You can't decide whether to take a raincoat to work or not if it's 50%. The forecasts are based principally on temperature and pressure. On the other hand, clouds contain charge. And you know that thunderclouds contain a lot of charge, but all clouds contain charge. And in my next book, which should be out in a few months, I describe the principles of weather, starting from first principles, going on to explain typhoons and tornadoes and whatever. And charge is absolutely the essence of weather. Easy water plays a huge role in that. In terms of health, I've presented to you a few a few expedients that you can use to maintain your health. Food, if you want to dehydrate or freeze, it's good to know something about those processes, which we've explored. And practical uses, filtration is one of them we're working on. Maybe desalination, we hope to go in that direction, and getting electricity from water. So there are many implications. And what I presented to you, a goodly portion of it appears in this second book. And in this case, the reviews are not very mixed. They're really, really positive. The book is extremely popular. And the drawings are by my artist son, so I do recommend it. Anyway, I think I'll stop there, and I'm happy to answer questions if there are any. Thank you very much for listening.
Thank you, Dr. Pollack. That was incredible. And the questions, I have mountains of questions, and I'm going to throw one at you before we open up the door. I know we have already a list of a lot of people who are really, really anxious to get something off their mind, ask some questions. I guess that of the many, I have to pick and choose something. So the one thought that I had, well, first of all, just to say, I don't think up until this moment I've ever found a more satisfying explanation, or at least a gateway to explain why snowflakes are hexagons, which has bugged me for years and years. And this provides like a really simple,
right?
Yeah,
Okay.
I mean that's a transition phase before it goes from the so-called liquid to the solid state is just incredible. So thank you for that one. I know Kepler was grappling with this 450 years ago, and I think he would be overjoyed to have experienced your class today.
Introduce me to him.
I'll see what I can do. I guess the question on the what do you call them, the breatharians? I didn't realize there were so many people who practice this technique. There's a lot.
I was informed by an Australian woman who we were in contact just the past few weeks, and she actually has workshops to guide people who want to become breatharians. And she told me, and unless I got the number wrong, but she thinks there are about 300,000 of them around the world. It's not unusual. I got a phone call from a dancer somewhere in California, and she said to me, sometimes I just feel like not eating. And she said, I'll go for a month or so without eating anything. I continue to dance, and you can imagine the energy that's required. And then I feel like eating again, so I start eating. So periodically, you should go for 1 month without eating anything and dancing. So
wild, just magic. Wild. And the question I guess pops into my mind in this case is, in your research, because it's not something I've really thought too seriously about. Many people do still suffer famine. They die of starvation, where there's still access to lights and they breathe. But so is there something different in the esprit, the meditative techniques, the mental techniques that are used by some of these more serious practitioners or people like this dancer that you've encountered as a common denominator?
Could be. I haven't studied it, but usually people who do this are spiritually oriented people who meditate and pray. And if we absorb light energy, infrared energy, it could be that the people who are in the meditative state or a prayerful state may be absorbing more than the rest of us, putting them in a position whereby they can capture more energy than the rest of us can. That's a speculation. I don't know if it's true or not.
Yeah, something to work with.
Yeah.
Okay, let's open up the door. Kevin was the first to get in there. So Kevin Champagne, go for it.
Hi, Dr. Pollach. Can you hear me well?
I can hear you very well.
Great. So first of all, excellent talk. Very, very, very interesting. I would like to go back to the practical applications of the ED water in terms of electricity production.
Yep.
Are you aware of an experiment done by Lord Kelvin called the Lord Kelvin's thunderstorm?
Is that the water dropper experiment?
Yeah.
Yeah, we built some in our laboratory. Please go on. Yeah.
Well, because I mean, it naturally came to my mind because when I, like 10 years ago, when I studied engineering, that's one project that I did with some colleagues. And I mean, it does work. And for people who don't know what this is, just to describe it, you have a water source where you drop two streams of water into two different bowls that are, let's say, metal bowls. Then you cross them with wires like this, and you put rings at the end of it. So what basically happens is just by the natural, I guess that's how we explained it anyway. By the natural state of it, there's a little bit more of negative charges on this side. So it charges the bowl negatively on the left side. Then it's connected to the right ring, which is negatively charged also, which creates a negative, electric fields, which push up the the negatively charged water droplets on the right side. So what goes down the right side are positively charged. And so what happens in the end is that you can create electric discharges when there's enough energy that builds up. So my question is, because you mentioned that when using infrared light, you could create a bigger, a bigger layer faster of easy water, which is negatively charged for you. So do you see an application of this experiment in conjunction with the easy water in terms of electricity production?
The contraption that you were talking about, we built it, and it works, but you have to we found that you have to kind of fiddle with it to make it work. It's not so easy, and but it does work, and it works beautifully. And I guess I never thought about that possibility because of the complexity required to construct this device. But it's certainly a possibility. What we were more interested in is the fact that you could have two containers of water, one with net negative charge and one with net positive charge. And because if you didn't have that, you'd never get a discharge between the two. Because many people argue it's impossible. It's impossible to take water, have a container of water, a glass of water with net negative charge or net positive charge. And that experiment shows that it is possible, and it can be sustained for a length of time. That was a reason that we built it. But I never thought about the possibility of that could be used somehow. Maybe you put your finger on something really interesting. Anyway, I don't want to belabor the point, but we never thought about that possibility.
Just
maybe. Yeah.
Well, I have some other questions, but I believe it's out of the subject a little bit, so I'll leave them for the end, maybe. Thank you again.
Sure.
I'll take the prerogative of moderator just to jump in since this topic just came up quickly. I didn't really take this too seriously when people share videos sometimes of cars that had been constructed to run on water. And I didn't really pay too much mind to it, but with what's being said here, could there be any viability to that design? Is this something that has already been tried out in prototype format and hasn't really gotten off the ground, or is that still in the speculative domain?
Well, I drove in one in Japan.
Oh yeah,
yeah. There was a company that they produce a special kind of water. We don't need to go into great detail. And they ran their cars on 50% diesel and 50% water. And they said if they compared to 100% diesel, it ran more efficiently, more effectively with the water. Well, you got to realize that, as I presented, that water is not just a blob of stuff in the glass. It can contain energy. So if it can contain energy, why not use it in a car? And and those who are familiar with it will know that this idea is not a new one. It arose, I think, 30 years ago or something. I can't remember the guy's name, but he was boasting that he could run a car on water. And I believe it's possible because it contains energy, and if you just do it the right way, it should work. He disappeared from the scene. Nobody knows. Stanley Meyer, I think, was his name. And he was boasting. He was showing videos of cars running on water. And I guess, the powers that be didn't appreciate his approach using water instead of gasoline, and he disappeared. Well, I don't know anything beyond that. But this is a continuing saga of people looking at that possibility. Of course, depending on where you go, the cost of water and the cost of gasoline. So I had a trip to Saudi Arabia, and someone was telling me that if you want to buy a gallon of gas, it's cheaper than a gallon of water. So it depends where you are and what's available. They have plenty of gas there. They don't have much water there.
Right.
All of their water comes from reverse osmosis, which is very costly. But they've got plenty of energy to do that. So yeah, let me stop there.
No, that's useful. Thank you. John Place. Are you still there, John?
Yes. Hello. Thank you, Dr. Pollach. My name is John Place. I live in Bogota. And yesterday was the solar eclipse. And we had clouds the whole day, so we didn't actually see the annular eclipse. But we did notice, my wife and I, that this was the first day in weeks with clouds. Primero. Secondly, during the eclipse itself, the 2 hours of the eclipse, the clouds looked different from the rest of the day. Third, during the eclipse, we both felt terrible. And fourth, after the eclipse, everything was back to normal. So there seemed to be some kind of electric phenomena that were completely different from the appearance of the eclipse. Would this have anything to do with the states of water that you're referring to? Or is it possible?
I would have to think that through. I mean, all I can say is that in terms of clouds and weather, it really the central issue is charge. Charge is so important in clouds, and and the sun's energy is important in in building the clouds. That's why often you can see that the bottom of a cloud will be flat and the top will be puffy, because the sun's energy is in part responsible for building it. And so I'm thinking as you're speaking, I'm thinking that the cloud, that suddenly the sun is blacked out, or partially blacked out, it's going to have an impact on the clouds, and the clouds may have an impact on you because what keeps the cloud suspended in the sky to begin with is a repulsion from the Earth. I didn't have time to talk about it, but the clouds are negatively charged, and the Earth is negatively charged, and so they repel each other, and thereby you can see stacks of clouds sometimes, one above the other, and the ones that have a lot of negative charge will be higher than the ones that have less negative charge. So charges really matter, and the sun is involved in building those clouds. And if suddenly the sun disappears or partially disappears, it's going to have an effect on the electrical properties of those clouds, which in turn may impact you, because you've got you've got a negatively charged cloud there, and you're sitting on the Earth, and it's going to induce opposite charge in you. So negative charge will induce positive charge, for example, in your head, if you're familiar with the phenomenon of induction. I guess what I'm saying is sort of more general. Is that charges up there have an impact on you, and so if you accept that, you can run through the scenario of the cloud and how the sun is impacting the cloud and how that affects you. So I don't have a full answer to that, but all I can say is that I can.
But it gives me an idea of what might have been happening yesterday.
Sure.
I have a second question, which is specifically about your own research. I think a few years ago, you proposed the idea that muscle cells are alternating between being charged with easy water and then releasing quickly the energy for the actual activation of the muscles.
Yep.
Has this been confirmed?
No, I don't think there's any serious laboratory that's studying or pursuing what we proposed earlier. We have, I think, more than 100 papers about muscle contraction, and then we switched from muscle contraction to water, and it turns out that that water is absolutely centrally involved in the contraction of muscle, but nobody's taken that up. When we were in the field of muscle contraction, we produced a lot of evidence. Almost none of the evidence fits the accepted theory of muscle contraction. And I wrote a book on the subject called Muscles and Molecules, published 1990. And practically every researcher in the field had a copy of it, but almost nobody read it. The field of muscle contraction was dominated by a famous Nobel laureate, Sir Andrew Huxley. And he was a member of the Huxley family, and he was honored with Nobel Prize and president of the Royal Society and master of Trinity College, Cambridge. And when he walked into the room, there was a hush. It was as though God walked in. And I discovered then that mattered a lot. So, people in the field who had a choice of I'm not sure what words to use, but following the path of a great honored Nobel laureate versus following the path of some upstart. It's easy if they want their careers to flourish. If you follow the distinguished Nobel laureate, there's a better chance that your career will flourish. And so our work on muscle contraction really received very little attention. On the other hand, a lot of students were produced in my laboratory who went on to exalted positions, but the ideas that were presented have gone nowhere. I hope one day they'll go somewhere, but I got to tell you, I'm invited annually to Calgary to present a lecture. So the person who invites me presents the standard story of muscle contraction, and then he invites me. It's been like 15 years, year after year, to present why that's wrong and what might be right. And in general, the students love it, and they ask me at the end, "Hey, this is so obvious, that you're in the right direction. How come nobody pays any attention to it?" And then I tell them the story of the hierarchy of scientific society, and who you are really matters a lot. And it's true in virtually every field. So anybody who comes up with an alternative idea, starting from Galileo or before, is critiqued. The people who have done research in the field, they don't like people to step on their toes. It's painful, and they squawk. And the scientific system today, which I've studied quite a lot, it is not conducive to revolutionary kinds of ideas. If you think about, I'm not sure of your background and whether you're scientific, but
I was an academic in computer science for 25 years.
Okay, so you understand very well. So suppose you have an idea that the Earth is round, right? And everybody knows it's flat. And you have some, quote, preliminary evidence because you've seen images from satellites and such, and you can see the curvature, and, so you're thinking, hey, it's not flat, it's curved. And you want to get money to study this because it's pretty important to distinguish whether the Earth is flat or round. And so you write a grant proposal and you submit it to one of the funding organizations. And the gatekeeper receives your application and, oh, this looks pretty radical. I think I'd better assemble the most prominent people in the field to review this and make sure this guy is not a crackpot or whatever. And who are those people? The very people you're challenging. So you have almost zero chance of getting money. That's the way the system works today. And that's the reason why, if I were to ask you, can you name a fundamental scientific revolution, not technological, like Zoom or whatever, but I mean scientific revolution, like as important as say the genetic code or the splitting of the atom that's occurred in the past 30 years or so. I think you'd have a hard time naming something that's really impacted your life. There are, and the New York Times just recently did a study on that, and they showed a steady decline in number of scientific revolutions or creative stuff over the past 50 years. I think this is a direct result of the way science is funded.
It's a direct result of what we call peer review. But
yeah.
I started a blog on the history of science, and I just wrote a few chats on a few posts on the Galileo's dialogue comparing the Copernican and the Ptolemaic systems.
Yeah.
And after analyzing the discussions between Simplicio, Sagredo, and Salviati, it's obvious why the Dominicans and Jesuits went after him.
Oh yeah.
Yeah. Because he was essentially saying the entire edifice needs to be taken down.
Of course, yeah, and the purveyors of that edifice are not happy about that, and they respond.
Thank you very much.
Sure, okay, we're in the same wavelength.
Yeah, I think most people here are sort of zeroing in on a very similar wavelength when it comes to some.
I think Matt would also have a few choice words for the Huxley family.
Yeah, it's unfortunate that Sir Andrew was captured in his family's legacy. That's too bad. Maybe one of their grandkids who's yet unborn might have a chance to be a real creative human being someday. Who knows?
Oh, I don't know.
All right, we have here Stephen Doyle has been waiting for a bit. Stephen.
Hi, thanks, Dr. Pollach. I really enjoyed it. I'm one of these crazy guys that actually has a grounded neoprene mat underneath my desk. I spend my workday barefoot on it. I have a grounded bed sheet or earthed. I have a hollow glass rod with, I think, easy, or I've also heard it referred to as structured water that I stir my water with. Supposedly that communicates the easy physics to the water that you're going to consume.
Yep.
So I've been on board with this stuff for a while. Some of the background I learned from it was from a diet and nutrition guy named Dave Asprey, and he's got the Bulletproof Diet World.
Sure, I know Dave. Yeah.
Okay, and he talks about, with his Bulletproof coffee, the longer you blend it, the more you get the structured water aspect to your coffee too. And I'm just wondering if there's a possible parallel between that circular blending motion, and I understand that the cell nucleuses actually rotate. And so I'm wondering, within the physics of this, is there a torsion field generated within the cell that helps contribute to the easy water formulation, or is there somehow, has anyone ever studied the possibility of torsion fields?
I don't think anybody has studied that. And the idea that the nucleus is rotating is new for me. I don't know where that is. This an observation or is it a theory?
I recall seeing that from a TED talk from a scientist who actually imaged it. I forget her name. I'll look for the reference. If I can find it, I'll send it to you via Matt.
Sure. I'd like to see that. This is new to me, so I'm afraid I have no comment on that. You know, the idea of torsion and such, of vortexing. So some people think that if you vortex the water, as opposed to letting it just sit there, it creates a so-called living water, a water that's different from stagnant water. And this was espoused early on by some famous naturalists. But I've seen, this is hypothetical. Schauberger was one of the guys, a naturalist, and I've heard a lot of people talking about vortexing water, and I would like to know whether if you vortex the water, that in the vortex you're creating EZ water, because living water, EZ water, I think they may be the same. But it's really hard to do an experiment like that because you have to look at the water during the time that it's being vortexed. And it's not so simple. We had some preliminary evidence that I presented in the book that whose cover I showed at the end. But the evidence was not really so clear. I really hope that somebody actually takes this up and does a really thorough job on looking at vortices to see whether they really do what people are thinking that they do. But thank you for your question.
Thank you.
Yeah.
John C. John C. Are you still there? And by the way, everybody is by default on mute, so you have to remove yourself from mute to speak. All right, we're going to skip over John C. and come back to him later. Monty in Mexico, are you there?
Yes, yes, Dr. Pollach. Related to your what you presented in another beaker and the whole thing with memory of water, I was reminded of the study in homeopathy, as opposed to allopathic medicine or naturopathy, where they use various remedies to cure diseases. In homeopathy, what they do is they take substances, either plant substances or mineral substances, and they dilute it, whereas you just get the essence of substance in a water. Are you familiar with that, or does there seem to be some intersection with what you're talking about, or hypotheses to pursue this idea that there could be something transferred insofar as within an essence, the memory of another substance that would be effective?
Yeah,
Thank you.
absolutely. Yeah, I'm familiar with homeopathy, widely demeaned as nonsense, but it seems to work. Some people think it's a placebo effect, but it's hard to explain it as a placebo effect when it's used in horses, and apparently successfully. So something is going on. And the idea is that when you do a dilution, 10-to-1, say, dilution, you reach a point where you should be diluting out any of the molecules of the original substance when you dilute enough times. And therefore, in theory, it shouldn't work. However, it could work if water contained memory, because the water could then contain the information that had been in the original substance that you dilute. And there's been a lot of work on that. One guy lost his career, Jacques Benveniste, was a famous French scientist who did some experiments on high dilutions, and he started with a laboratory of some 50 people. And when he tried to publish in Nature, they responded with vengeance. They came back to his laboratory to look over his shoulder, and they had a committee of people, one of whom was a magician, the amazing Randy. And they couldn't find a trick that they presumed was going on, but they still said, it's a delusion, it's a trick. But they couldn't identify the trick. And his career went from an esteemed French scientist to, down at the bottom, which was really, really very sad. So you know, I think the easy water has something to do with that. If you see, one of the critical features has been demonstrated that you have to shake. You do the dilution, and then it's called succussion. You take it and you shake it. The shaking is very important. And if you don't do that, then everything is lost. It was demonstrated by a Russian scientist, and his name is Konovalov. And if you're into that, his work is really worth looking at. A famous, distinguished academician from Russia.
Yeah.
And he showed that the energy from the environment is important and the succussion is important. And so, in what way? Well, if you take easy water and you shake it, what we found in the laboratory is you break up the easy water into a lot of little easy waters. And then when you dilute it, some of those little clusters of easy water remain because you have a whole lot of them. And when you dilute it, obviously, you know, maybe 10% of them, if you dilute 10 to 1, are going to remain. They contain the information. So you keep perpetuating the information in that way, and you can do practically an infinite number of dilutions. And as long as the easy water is there and grows each time, the information will be retained. So yes, you're absolutely right. This is an important manifestation of the presence of easy water. Thank you for bringing that up. Check out Konovalov.
Yeah, that seems like an important point of intersection that has to happen more, because I was thinking about all of the interesting practitioners, people who have been innovating various approaches to homeopathy, and obviously there's a lack of standardization and communication, so it's a little bit of a wild west situation, but there's definitely results that work really well. And to think about, I tend not to see too much of an appreciation for the electromagnetic component of how light especially is interfacing with the body and the fluids. There's sort of more of a focus on the chemistry of it, of the living process, and not as much of the EM aspect. So to see that there is some cross-pollination is good. Is there a lot going on? Do you find that there's a convergence right now of people from the fields that you're working in, and people in homeopathy or alternative medicine, as it's so-called, communicating and sharing ideas?
You know, I think one of the nucleating sources is indeed the conference that we run each year, the annual conference on the physics, chemistry, and biology of water. You know, I make an attempt to invite people with really interesting results, not necessarily the sort of standard stuff that you'd see, but people with seriously interesting results. And I think it's beginning to pick up. I'm told by colleagues that people are talking a lot about water these days, whereas 10 years ago they didn't. And people are beginning to recognize that the properties are so interesting, that water is, for example, an energy source. And, you know, if it's an energy source, then you can think of many applications of this energy source, not just producing electrical energy, but you know, as I said, in weather. And I'm now writing a book that argues that this kind of thing is responsible for powering volcanoes and earthquakes. And I think there's good evidence for that. Right now, people haven't a clue where the energy comes from. They think either that the Earth was endowed with high energy, either through radioactivity or heating or something when it was born. But you know, that was it 4 billion years ago or something like this, and it's a long time. So if you think that the energy came from an Earth that was endowed with heat, you know, you'd think maybe after 100 or 1,000 years the heat would dissipate, and we're now at 4 billion or something like this years. So it's hard to imagine that this is the case. But you know, in the case of easy water, there are deep aquifers way down called primary water, and if some of that water becomes EZ water. As the EZ water forms, protons form as well beyond the EZ. And those protons are basically freely dissolved in water as hydronium ions. They repel each other. And because they repel, they create a pressure. And when this pressure becomes high enough, it's possible that that's what's responsible for the volcano blowing. And this could cycle itself again and again to account for the fact that volcanoes tend to blow periodically. They just keep doing it. And earthquakes also. You know, you have two pieces, two areas that are up against one, like two pieces of sandpaper. You know, they won't slide, but if you can separate them by a small amount, then they slide easily. And so if you can imagine protons getting in between those and exerting the force that we've been talking about, they separate and boom, you get an earthquake. And here in the Northwest, we're expecting a 9.1. It occurs every 300 or so years, and we're looking forward to another one. It's been 375. So I'm not sure. Maybe I've gone astray from the original.
No, it's all connected. We get, and I mean, you know, it's a something we take for granted, right? That we have this cold, I don't want to call it vacuum, but we've got like space, and within space we have these planets, and around the planets we have they're circulating this ball of fire, this heat, and which you would think should over. How would that orb of heat called the sun be able to maintain itself and exert energy that it is constantly giving off into the solar system? And where's its energy coming from? And is it, you know, like all of these questions, we sort of presume that we have all the answers to, because we've all seen the images of the sun cut up and we know exactly what's inside of it. And there's such a lack of humility that prevents us from sort of appreciating how some of these things like volcanoes and earthquakes could be addressed in a much more healthy manner if we just admitted that we don't know a lot and that there's certain things like you've just brought up. Where does this energy come from? That's you know, inside the earth.
Yeah, I'm right with you on that. And you know, with regard to the sun, I got to tell you that I have the same question you have. Where does the energy of the sun come from? That's not at all clear. You know, and I think that's kind of the ultimate question that needs to be answered, because there's so much energy coming from it. How, where does it come from? Yeah.
Scott has been waiting for a bit. Let me ask you this. How much time do you have right now? I feel like
well, I have a few more minutes.
Okay.
I can't go on endlessly because
of course.
Yeah.
So let's do this. Let's do Scott and Kelly, and we'll round it up there. So Scott, if you can make it sort of a concise, quick question, and we'll go to Kelly.
Okay, I'll do my best because it's so interesting.
Well,
And you're welcome. Oh, I was just wondering if you gave a lecture not quickly on the Electric Universe Conference. I think you might have. I think
I
did
gave
you
a few. Yeah, sure. Yeah.
Okay. Because that's kind of I'm a real proponent of that theory of cosmology, and there's a number of people I think on the call who are, and it's just a whole new perspective. So just wanted to know if you are in touch with Dr. Jerry Tennant, who did a great presentation, you know, healing as energy and the effect of the cell, which was just a totally mind-boggling way to look at it.
Yeah. I'm in touch with him, not on a daily basis, but yes, I think the two of us are thinking along similar lines. You know, he's a clinician who has interest in electrical stuff, and I'm a basic scientist who also has interest in the electrical stuff. So there's a kind of crossover. You know, and he has a book, it's called Healing as Voltage or something like that. And basically he's espousing the idea that electricity is so central. And there's another book by a guy named Mark Noble, who has similar ideas. He says that life is run by electrons, and there's a lot of interest coming together to suggest that we as humans, as living souls, are run not so much by chemistry, but a lot more by electricity, by charges.
Absolutely.
And my next book is called Charged. There is a subtitle, I forget exactly what it is, but I argue in the book that should be coming out in the next 3 or 4 months, that our environment, so much of our environment is run by electrical charges. We don't recognize it, but if you go through and analyze it, you'll see that that's the case. It goes along with the electric universe view, which is not one particular view, but a bunch of diverse views that, that argue that charges and electricity is really important in nature. I agree with that.
Did you have a
the other-
follow-up question, Scott?
Yeah, just the work of Dr. Thomas Gold. Had a specialist here in Vancouver who was a big fan of Dr. Thomas Gold, who's a PhD from Harvard, and he told me about to do with the climate change issue and fundamental theory, what you're just talking about, how I think it was the helium ions drag up the O3 from the Earth's core. It's related to as well abiotic theory of oil production, and then bring up the O3, and then the O3 mixes with carbon in the higher levels, and that's where we get carbon dioxide and whatnot. And this whole creation of the atmosphere. I'm just wondering if you had looked at his work at all.
No, I'm afraid I'm completely unfamiliar with what you're talking about. Sorry.
Okay. All right, Kelly.
Hi. Yeah, I don't know if it's a question or comment. It's just I just wanted to mention I've heard of athletes, they would get like cramps during whatever they're doing. I even had it myself playing guitar. I get like little spasms, cramps in my hands, and they would take dill pickle juice, and it would, like, you drink it and immediately it would the cramps would go away. I even tried it and it worked. And scientists couldn't explain like how it worked, because the time, like it was so instant that they couldn't explain like how it would go through the stomach and with the nerve reaction to remove the spasms. So I just thought it might be connected to the easy water.
Yeah, well, my comment is more general than that. If you feel tired, and you take some sugar or some cookies or whatever, you'll notice that you feel energized in a matter of like 5 or 10 minutes. Doesn't take long to feel energized. In contrast to that, something going through your GI system may take 30 minutes or 40 minutes by the time it gets into your blood and then into the tissue. So you're getting something from the food more quickly than you'd expect, and from the pickle juice too. And so I've been thinking, without evidence, that what happens is that when you eat food, the food is typically negatively charged because it's full of easy water, whether it's vegetables or meat, that the electrons, they're free to go wherever they want. The food comes in, the food contains excess electrons, and those electrons will go wherever nature takes them to go. And the electrons are important for creating easy water. You put electrons into water, we found, and it converts the water into easy water, and you need easy water for everything you do, including your muscles and such. And so again, this is you might say speculative, but I think it's possible that immediately when we eat or drink pickle juice, electrons come in, and the electrons go wherever they're absent. And in the case of muscle contraction, when you feel a spasm, when you're contracted up, the after a contraction, the energy requiring step is to return from ordinary liquid water to EZ water. That goes from neutral to negative. So if you get electrons from somewhere, that conversion can occur easily. So if you got a cramp, it means your muscles are remaining contracted. They can't relax. In order to relax, to go back to the initial state, which is the state where you have EZ water, you need electrons, you need negative charge. It might be, this is a speculation, that from the pickle juice, the electrons are coming, again, as I said, speculation, and going to your muscles where there's not enough negative charge to restore your muscles to the relaxed state. They come and supply it. And so your contraction is then, or spasm is relieved. That's a speculation. I have no evidence for that.
No, that's a very solid, interesting hypothesis.
Well,
Kevin, Kevin wrote to me begging if he could please have a follow-up question, and so I can't say no to Kevin. Kevin,
of course.
and I love maple syrup, Kevin. So you really you won me over.
Well, it's more of a comment than a question, so I'll try to be brief. It's basically I come from a family of maple syrup producer, and what they basically do these days is they collect the maple water from the trees. They collect it into a used basin, and nowadays to increase production, they use reverse osmosis to facilitate the process from the water to the syrup. So I'm just throwing the idea out there that
they use
yes.
reverse osmosis. I don't understand how.
So they want what they want to do is to evaporate. Like in the old days, they would evaporate the water to keep the sugar and to increase the concentration. What they would do now is that they use a machine of reverse osmosis to separate the sugar and the water, and then they take the part where it's more concentrated in sugar, and then they boil this part. So it gets the process a little bit faster and easier, I guess. But my comment is just that they collect the water from in tubes to the basin. So I mean, applying the process of desalination, but for maple water, would I guess be less costly and the same with the same efficiency. I don't know. I'm just throwing the idea in the universe out there.
Or I would need to look into it a little bit more closely in order to comment. But I mean, the whole idea in maple trees. I've got one right outside my house here. It's not one that produces sugar maple, but some of the trees are 100 meters high. And the question is, well, how does the water get up to the top? If you have a column of water that's 100 meters high, the pressure at the bottom is enormous, but the water, it doesn't go down, it goes up. And I think my comment is, I think the mechanism that I was talking about, where you have a tube, like a Nafion tube, and the water flows through, the principle underlying that could well be similar to the principle that's used to get the water from the bottom to the top of the trees to go into the leaves. It could be, it could be a mechanism that's used widely throughout nature to accomplish things that we don't understand.
Thank you. That could be part of the basket of different marketable products that will eventually emerge or is emerging. You might add another feature to that basket. There was one thing that just popped in my mind. You mentioned a Russian scientist, Konovalov, or
Konovalov, Konovalov.
Okay, thank you. That was it. I just wanted to know that spelling.
Yeah, he passed a few years ago, but he was an academician, which is the highest level that you can get in academic life in Russia. And he was he was also the rector of his university for, I think, 12 years. And he was the director of a world famous laboratory. So, you know, this is no ordinary scientist. And he took up the idea of homeopathy in his later years, and he produced extensive work. And I think his work is the most fundamental of all work on the subject. And a lot of it is in English. So if anybody is interested, go check him out.
Is that Alexander Konovalov?
Yes, it is. You know him?
Okay, thank
Knew
you.
him? Yeah.
No, it was I who asked how it was spelled so I could find out who he was.
Yeah, Alexander Konovalov. Yeah.
Thank you. Thank you so much, Dr. Pollack. And I got to say, I think, you know, just to round this out, there's a story that Plato had conveyed regarding a crisis that his people of ancient Athens were going through. They're really in a downward spiral, and he recounts this story of the people at Delos, who were that had a similar problem. There were people who had greatness, they had a lot of potential, but they had forgotten certain things, and they were going into war, pestilence, famine. It was bad, and some of the leaders went to the Temple of Delphi and asked, "What do we do?" And they said, "Well, you have to double the size of this particular cubic shrine, and your problems will be solved." And they couldn't figure it out. And part of what Plato was trying to get at in the lesson that he is conveying is that it was when people lost the sense of curiosity, the ability to creatively problem solve questions like the doubling of the cube, the volume, that when there was nobody within that society that was able to even ask the question or solve it, that society lost its vitality, its capacity to make it through very basic human problems that we would then create for ourselves. So I think we're now entering a world of we don't have any shortage of crises. No, most of which are unfortunately man-made. We do have a shortage of creative thinkers, and I think that this type of presentation, this type of reminder of it really awakens a sense of awe and wonder, but also a sense of confidence that we have capacities to make revolutionary discoveries into the fabric of the universe itself, and have that play back into creating a better world for our kids. So I really thank you for just introducing this concept and giving people a much better sense of what water is, this thing that we live in, we are, and we don't even think twice about.
Well, your comments are very kind. Thank you very much. I live for that. I tell you, the curiosity, and I hope I live forever, because there are so many things that I want to ideas that I want to flesh out and present to the world for their consideration. It really moves me. But thank you so much for that. Appreciate it.
Thank you. All right, everybody. So we'll catch everybody next week. We begin a new symposium on the Dark Age Renaissance periods. We're gonna have a story of some work by Gerald Pollack next Sunday on the real King Arthur within the geopolitical world of the 6th century. What was he doing? Why was his story co-opted by forces who despise him, and turned into a bit of a parody of what he actually was? So that'll be the first of a series of lectures next Sunday at 2 p.m. for those listening. And Dr. Pollach, once again, thank you so much.
My pleasure. Thank you. Thank you.
Thank you. Thank you.
All of you. Yeah, much appreciated. Okay.